Hi everyone, my name is Anthony. Most of you are here because you've watched our short teaser video we created. I have to give a thanks out to my friend Michael, who actually did the video editing on that. If you haven't seen it, you can click on the link in the description to check it out. In this video, I'm going to go over the technical details of the simulator I made. First, let me give some background about myself. I grew up in a family machine shop, so I'm a machinist and a CNC programmer. I'm also skilled in mechanical engineering and designing from my machining background. Currently, I am a C++ developer for a company called SolidCam, where we write software for computer-aided manufacturing. I am not an electrical engineer. I am also not a microcontroller engineer or programmer. I have learned these skills by searching the web and from other YouTubers. I would highly recommend the YouTube channel Great Scott to anybody wanting to learn electronics, as the guy produces amazing content. Okay, enough about me. I would think the main two questions about my simulator would be, how did I make it? And why did you make it? Let's start with the number 2 because it's shorter. Let me say that this project spiraled beyond anything I had originally imagined. I love watching MotoGP, and because of that, I enjoy playing the MotoGP game on my Xbox. 2 years ago, I started with a simple idea of making a foot-activated shifter that would work with my Xbox controller. I figured I could use 2 foot switches to close the contacts on the A and B buttons on the Xbox controller. I was able to get 1 foot switch working, and then I kind of dropped that project for a little while. Then I took a motorcycle course with Yamaha Champions Riding School at New Jersey Motorsports Park, and it was one of the funnest things I've ever done. My problem is I wanted to experience track racing more, and I also wanted to practice. So I thought to myself, how awesome would it be to wake up in the morning and work out by riding my motorcycle? For anyone who has tracked a motorcycle, you know how physically demanding it is. For anybody who knows me, they know I hate to work out. I love sports, specifically hockey, but I think I have the attention span of a gnat, so straight up working out is not for me. I know everyone who rides a motorcycle is saying to themselves, this guy has a stationary motorcycle, riding that is not a workout. I can answer that my simulator is definitely not as demanding as the forces of real track riding, but it's still pretty hard. For instance, my resting heart rate is 67 beats per minute, and it averages around 110 while playing the game. It's no cardio workout, but it's still something. Let's move to the fun part. How did I make it? Well, the main parts are a Microsoft adaptive controller, an Arduino Mega, and a lot of 9-axis MPU 9250 accelerometers. In summary, the Arduino reads the sensors that are mounted on the bike and my arms. Then the Arduino controls the Microsoft adaptive controller. I know, it sounds so simple, and that's exactly what I thought before I started. I mean, I know C++ programming, and I know how to design pretty much anything in SolidWorks. Our phones have accelerometers in it, and so does my son's racing drones. So how hard could this be? Yeah. Well, I was stupid and naive. It was not that easy. Electronics are not simple, and people who know electronics are amazing. Okay, let's get into the details, specifically the sensors. First, all the sensors are 3D printed and are what I consider soft mounted to the motorcycle. This means that all the mounts are clamshelled to pinch on the motorcycle using small 3mm screws. I didn't drill any holes on the motorcycle, and I don't use any screws or bolts from the existing motorcycle to hold anything. I ride my Ducati, so I needed simple mounts that I could take on and off and didn't hurt the bike. The only special mount is for the shifter, because that mount has hard stops to limit the shifter. I didn't want to be running through the gears, so I limited the travel with the hard stops. It's a bit quirky because the travel is about 20 to 30% of the normal shifting travel, but it works. The arm mounts are pretty cool because I designed them so they have adjustments on 2 rotary axes. This made my prototyping easier because I could level the sensor to any orientation I wanted. I played around with many different locations on my arms for the sensors. For most of the sensors, I'm only using the angle calculation from the accelerometer. In other words, I measure how much the shifter rotates up or down, or how much the throttle rotates. For the brake, I am using the magnetometer, and I have a small magnet taped to the end of the brake handle. I measure the amount of magnetism to calculate the distance of the brake handle. I do have a linear potentiometer mounted to the steering dampener, but I don't actually use that. All the steering is done by the leaning of your body. There is a joystick on the left handlebar, and that's for 2 reasons. Most important, it allows my 9-year-old son Jack to play the simulator, since he can steer with the joystick. He's my partner in crime on this project, and he's been my beta tester from the beginning. And number 2, it can be used for navigating the Xbox menus in the future. Regarding the TV setup, you will notice that there are 3 TVs with LED strips along the sides and top. The LED strips were added as a debugging feature so that I could verify that I was reading all the sensors properly. However, it became helpful to have a visual feedback while playing the game. The LEDs show throttle on the left and brake on the right. Across the top, it shows the amount of leaning. I'm sure people are wondering why there are 3 TVs and why do they all show the same Xbox image? Well, I started with 1 TV, but I realized something was wrong after my first laps with the leaning. Something felt unnatural, and I realized it was my head twisting back across my body to look at the TV while I was leaning. It then hit me that we look where we turn riding motorcycles, so my head naturally wants to look to the left or right while leaning. My solution was 3 TVs and an HDMI 4-port replicator, and it actually works pretty awesome. It feels natural to move your head from the center TV to the side TVs when you start leaning. This brings us to the Arduino and programming. I would say this is where most of the magic happens. The code is currently about 1,500 lines. The sensors are read every 12 to 14 milliseconds, and I update the LEDs every 36 milliseconds. Working with the accelerometers was more tricky than I thought because they're very noisy. I have all sorts of tiny tricks and smoothing code to handle each sensor based on what it does. The lean calculations are obviously the most complex, and they drove me crazy. Yet, the shifter was also a pain because of the short travel and the quick nature of downshifting. All in all, the code works well, and I can't really complain about any specific problem while playing the game. I would love to make the arm sensors wireless, but that's a big project itself. Well, at least for me it is. I think that covers the main portions of my project. Even though I did most of the work on this project, I used a lot of brainstorming with friends that I work with. There was a lot of researching and trial and error, figuring out how to make this thing work. Help from others was incredibly important. Thanks for watching, and if you have any questions, put them in the comments and I'll try to answer them.